Welcome to Out of the Blank.
Welcome to another episode of Out of the Blank podcast. I'm here with Mr. Byrnes. It's a pleasure to have you on the show. Can you please introduce yourself to everyone out there listening?
Sure. Hi, I'm Chris Byrnes. I'm a senior lecturer in the University of Sussex. I research on the early universe and a possible dark matter candidate called a primordial black hole.
Before we jump right into the primordial black holes, I got to ask how you even got interested in researching the early universe. Before there was nothing, and then there was the Big Bang, and then whatever came after.
Well, I think you've made it sound interesting yourself, right? It's one of these deep questions of humanity. What is the universe? What's it made out of? How did it begin? Was there a beginning? These are all just intrinsically fundamental questions. But I started off I guess like many kids, I looked a little bit at the sky, saw stars, wondered what's up there. I was pretty good at maths at school. I actually studied maths, not physics at university. And then I was looking, what can I apply this to? Sort of what are the exciting questions out there? And cosmology is where I fell. There's plenty of other ones. But
Now, is primordial black holes, is that something that we've always known about? Because I feel like the more that technology keeps expanding, like we got the James Webb telescope up there now doing some work for us, but it seems like we're coming across things that were theories before that actually could exist. And I'm holding out for alternative dimensions. I don't know. I'm still going to put, one egg in that basket, not all of them. But I think it's interesting because the more that technology goes forward, we're starting to discover more, not only about our own universe, but other universes that are also out there.
right, so that's a lot of information. So primordial black hole, it's the idea that you might have had black holes forming in the very early universe within about a second after the Big Bang, which is long before stars. So our normal picture is you get a star, it forms perhaps 1 billion years or so after the Big Bang, then it burns up its fuel, eventually it goes bang, and sometimes it leaves in the middle a remnant called a black hole. Now that sort of black hole, we know that sort of thing happens. We've seen it happen in telescopes. But there could be other types of black holes which predate the first star. And if they exist, then that tells us something about how the universe was created and what's in the universe beyond dead stars, which, as I say, we certainly do know exist.
So are there various types of black holes? Like if we know that a star dying can sometimes create one, if this came before that, if it's like the first primordial, I'm guessing is like the beginning.
That's right. Yeah.
So I'm curious, if there's no stars to be able to form that, was that a cause of the Big Bang creating these things? I mean, do they have different characteristics than a regular black hole?
That's a very good question. So there's something called the no-hair theorem, which I'll explain a little bit. It goes back to Stephen Hawking, one of the genius of our lifetime, although no longer alive. So he found that once a black hole has formed, it can only have very, very few properties. Basically, it has a mass. It can be rotating, just like the planets are rotating. The Earth goes around every 24 hours. And that's basically it. So once the black hole has formed, even though it can form in many different ways and from different things, you lose that information. It's all hidden in the center. And unless you're willing to, lose your life falling into that black hole, you'll never know directly what's inside or how it formed. So that's challenging. And it means once you see a black hole, you don't actually know just from that one black hole how it formed. You have to do some sort of detective work of what's the most likely scenario of how it might have come to exist. So that's a tricky question. But some of my research has been, given that we've seen, in quotation marks, you don't really see a black hole, but we've seen the impact of black holes, for example, smashing into each other, creating gravitational waves, or we've seen gas clouds circling around and falling into black holes. and that gas gets very hot as it starts spinning very quickly. We can only then, yeah, we have to look at the properties. What are the masses? What are the distances? Where are those black holes? Are they inside galaxies? Are they in between galaxies, etc.? To try and, in a sense, guess, but a more scientific form of guessing what their origin might be. And so far, we don't know for sure if there are any primordial black holes or not. It's possible that they're all from dead stars forming later in the universe.
Who was the first person to even bring up the idea of a primordial black hole?
And there's a little bit of a dispute about that. Most people would say Stephen Hawking. He was undoubtedly the first to do much with them, but there was an older paper of something a bit related, or written in Russian by Novikov and Zeldovich a few years beforehand. But this was during the days of the Iron Curtain. We're talking back late 1960s, early 1970s, so there was no cross communication. So I think it's fair to say this idea was independently came up with more than once. Um, yeah, we're talking about 1970.
Would it even be around a primordial black hole? I mean, that would be something we'd probably be able to notice, right? I mean, if they were already creating the idea of it back then, you'd think the technology would have. I'm not blaming technology for anything, but I'm just wondering is like, we know that their stars die, creates a black hole. How long do those black holes last? Do they fade away? And you're talking now about the first black holes. So we might not know what created it, but if we're able to even find that one even still exists, I start looking at like I don't know if you've seen the graph of the timeline for the millions of years after the Big Bang was created, and you start seeing the lights start popping up. It seems like there's a bunch of chaos in the beginning, and it starts fading out to a more crystallized kind of not I wouldn't say more noise, but less noise, a little bit more accurate depictions of the universe and how that stuff is. But there's a lot of blank spaces where it's very dark, and I start going, was that something that a black hole did that made all that noise start to fade away from the beginning to where it's at now? I know it's over an extended period of time, and you can add that in as a factor, but I have to think that if there is a concept such as primordial black holes, that has to be where a lot of that light died away, where a lot of it just vanished, and it seems like now there's just empty blank spots of space.
Um, it's not it's not required, no, to have a black hole to do that. You've got to remember that the early universe was much, much smaller. Things were much closer together. And so if you compress a gas, like just pumping up your tire in a fuel station, if you keep pumping and pumping, it'll get hotter and hotter and eventually it will burst. So the early universe was like that. It was full of very hot gas. And then the universe grew in every dimension and grew outwards. It got emptier. And as it grew emptier, it grew colder. So you don't need a black hole to do that. You've simply got this expansion of space, everything getting diluted, getting cooler, but then gravity is acting in the opposite direction, right? The universe is growing, making things colder, but gravity is trying to attract things back together. So sometimes the gas clump gets attracted close enough to each other, strongly enough to get hot and start nuclear reactions, and that's a star. If you've got black holes, then they act like a strong gravitational source. The gravity is incredibly strong around a black hole. So JWST, you mentioned that at the beginning, right? It's an amazing new view to the early universe. It might be able to see evidence of primordial black holes, because if there were black holes around at the same time as the first stars, then they have to be primordial. They can't be dead stars if if they were there at the same time as the first stars. But so far, JWST is very new. We don't know really in detail what it's seen.
Now, would that lead to maybe a factor that might have created the Big Bang in the first place?
No, not really. We don't. The truth is, what started the Big Bang, we just don't know. But at least in the picture of Hawking and others afterwards, a primordial black hole, even though it's very, very early in the formation of the universe, it's still definitely after the beginning. So it's not the beginning itself. It's a function of what was the initial condition, what was the very early universe like, but it doesn't explain why there was a beginning. I'm afraid. I wish it would, but it just doesn't.
Well, when it comes to even discovering or trying to find at least resources or anything that would prove its existence? I mean, is that just a technology thing we have to wait on to be able to? I mean, the hardest thing is trying to predict how the universe before there was nothing, what happened, what created the Big Bang. 'Cause we're using technology now. It's like if we had a time machine, it'd be 1,000 times easier, but there's none of that right now. So we have to use tools and make, predictions and models and things of that sort to be able to kind of reverse and just backtrack a little bit to predate, what was going on around that time period, but there was nothing.
So it's interesting, like, how do we know that there was something like a beginning? Um, the important observation is that the speed of light is not infinite. The speed of light is incredibly fast. It takes, say, 8 minutes for the sun to shine light to reach us. Okay. If you, though, look at another galaxy, they tend to be millions or even billions of light years away, meaning it's taken light a billion years or perhaps even 10 billion years to reach us. So we see in the past. So in that sense, we don't need a time machine to see to the past. But and there's a catch, which is light has only existed for some time, which is a bit less than the age of the universe, or at least light has only been able to travel through the universe for some period of time, which isn't exactly equal to the age of the universe. So we can look back in time further and further. The further away we look, the older the light is, the further back in time we see. But at some point, there is no more light. We've seen the edge. Well, not the edge, but we've seen that the oldest light which still exists in the universe today. And even if we existed in the past, we'd still have that same problem. There's a limit to how far back in time you can see because there simply isn't any light older than a certain age. And
Well, you mentioned in the beginning kind of like this expanding out in a sense, and gravity is kind of pulling it all together a little bit. I mean, there's gaps or there's areas in space that are just complete nothingness. I mean, is it like lighting a light bulb in a room or something? Like if the farther away you get from the light bulb, the farther the light fades out. And if because I've heard, I don't know if this is true, but I've heard like Venus is slowly distancing itself, and over it's going to be like a long period of time, but it's going to eventually get out of like the alignment of all the planets. It's just going to pop out. I don't know if it's Venus or if it's Neptune. I don't know if you've ever heard of that before. Oh,
no,
no. I saw it on like one of
it might be
those.
true, but no, I haven't.
I saw it on like a Science Today article, one of those,
Mhm.
and I just started thinking, I was like, it's like everything's moving like an inch or inch closer, inch farther apart. And I start going, I mean, is that just how we're just having we're able to see certain parts of space right now is because the area that's lit up and that'll keep extending out farther, maybe over a long period of time, but there's still areas where there's nothing. And I'm guessing that's just where the light hasn't reached to yet.
Um, so light, there are different things going on. The fact that the speed of light is finite does mean that we can see in the past because it takes time to reach us. But that initial light, it was actually everywhere. So the whole Big Bang, the beginning, was everywhere. And that created lots of temperature, lots of radiation, light, literally everywhere. As the universe grew, that cooled down, but that some of that's still left over. It's called the cosmic microwave background. Not sure if you've heard of that. Back in the old days of analog TVs before digital, if you switched it onto off any given channel, part of the snow that you saw on the screen was what's called this cosmic microwave background, which are these sort of cold light particles in the frequency that old-fashioned TVs, can pick up, traveling through space and traveling through the atmosphere onto your TV aerial. That is the oldest light, and that's actually everywhere. There's nowhere it hasn't reached. Um, I'm not sure if that's making sense, but there is light everywhere. It's just not the light you can see with your naked eye. It's too faint and it's too cold to be visible. But using other equipment, we can detect it, and we have. It was actually detected in about the 1960s, and that was, for many people, proof of the hot Big Bang. The fact that there's this sort of glowing light in every direction, all around, everywhere, filling up space. Well, I say filling up, it's everywhere in space, but it's very faint, it's very little. So there's nowhere in space, even in between galaxies, when you're very, very far away from everything. It would be very, very dark, but not black. It's never completely pitch black.
Well, I think the difference with a dark hole is the fact that anything that goes into it, we just never see again. That's why you mentioned in the beginning about if you just go through it, if you're willing to lose your life, basically. It's like the movie Interstellar. We don't know what that does. And there's many theories about what leads to the other end of a dark hole. I know some people that think it's another dimension. I know some people think it's like time travel. It's just interesting to me because it's like we don't ever have anything in society. I mean, we have things that we can question and we're still trying to find answers to, but nothing that has the answer that there is completely nothing. You know what I mean? Like that's just our conclusion right now because anything that we could think about, like light goes into it and it's gone. Like this just is like it's when you see those cartoons and it's just all a white screen and there's nothing and there's like one character. He's like, where'd everything go? There's no scenery drawn. That's what a black hole is, but it's just everything's done. It's just dark. And it brings into questions of what is like what are your ideas with a black hole? What's the importance of studying it?
Right. I guess why I study it, there are two things. One is it's possible, and I think it's a really cool idea, that there have been black holes around since the first second or so after the Big Bang, which are everywhere in space. They're just very hard to detect because a black hole is black, as you say. So how do you find it? You can only look sort of for the effect of gravity, because the black hole still exerts a gravitational field, which attracts every other things into it. Um, and also, if they do exist and if we can find them, then that will tell us something very exciting about what happened in the very early universe. And it will tell us something very interesting was happening very shortly after the Big Bang, with big differences in space, where you've got some very, very dense regions which form black holes, and some quite empty regions in between them which don't collapse by gravity. Um, so that for some people I know, theoretical physics always sounds very hypothetical, and it is. But we're searching for some of the most amazing things which could exist, and unless you look, you'll never find them.
Well,
But they might not
you're putting
exist, and
together
that's just a fact.
you're putting together a puzzle right now, and that's what's interesting about it is trying to discover what it is. But I feel like there's more of a fear aspect. Like whenever someone explains a black hole to me, I just start getting nervous of like, can these things pop up anywhere? And are we going to get sucked up at some point?
No, we won't. No, that's an interesting thing. So people often think, for example, now the sun in the center of the solar system. People worry that one day, if it turns into a black hole, we'll fall into it. But that's wrong, because the gravitational attraction of the sun is given by the mass of the sun. If it forms a black hole, it will still have the same mass. It'll be much smaller, it'll be black, we'll die of cold, but we won't die by falling into the black hole. The Earth will keep going around the black hole, which replaces the sun, if that ever happened. And it wouldn't change the orbit of Earth. So the total gravitational attraction from us to the sun will be exactly the same, whether it's a big glowing ball or whether it's a small cold black hole. Um, it'd still be very bad news. It'd be the end of life on Earth, but it wouldn't, not because we'll fall into the black hole. And that's a common misconception.
It doesn't mess with the gravity. It doesn't mess with like the actual, I guess, power of what the object is. It just disappears it from our eyes.
That's as long as you're far away from it, and we are far away from the sun. We're something like 100 million kilometers away, 100 million miles for the US audience from the sun. It doesn't change gravity. If you're close to it, it does. If you're close to the black hole, gravity changes a lot. But by close, I'm talking about a distance smaller than the current size of the sun. So if it shrunk into a black hole, it would shrink from its current size, which is something like 1 million miles, down to about 2 miles. Okay, which is just mind-blowing. It's going about something with 1 million miles across, shrinking down to a few miles across. Now, if you went close to that black hole, meaning a few miles away from the surface, you would feel the effect of gravity very differently. But that's a distance which is absolutely tiny in astronomical terms. And from the distance of Earth, it wouldn't make any difference. We would just feel the same gravitational attraction, no matter what it does, whether it's a black hole, a star, anything else.
Has there ever been any ideas or just experiments of trying to launch something into one of these black holes and see what happens?
No. Well, in science fiction and in popular science, it's sort of yes, but not any serious discussion. No, there's two problems. Firstly, there's a practical issue, which is we don't know of any black hole close enough to Earth to reach it in a human lifetime, even if you were traveling faster than any rocket built so far.
I just meant an object. I didn't mean a person.
Yeah, but I mean, it would take that object so long to reach it that it would just, it would take many centuries at least. So it's not very tempting for a funding agency to pay for an experiment which won't have results in the lifetime of anyone alive today. That's a practical issue. The other theoretical issue, which I think is actually the deeper one, is if the thing went into the black hole, it, what would we learn? It would just vanish in for us. It would, as it sank through the event horizon of the black hole, it wouldn't be able to send any signal back to us. It might still work, but to us, it would just be lost. So why would we pay lots of money sending something which we know we're just going to lose? And then,
What do you mean? What do you mean science? I want to know where that thing's going. It's something had to happen to it. It doesn't just, it's not like a I wouldn't say I'm trying to even think of the word. It's not like an eviscerator. It doesn't just vanish or get destroyed. It just goes in and then there's no way for us to get it back out. Is it like it's not getting sent somewhere. It's just something's happening to it between that when it goes into the black hole that changes something about it. Is it changing particles? Is it changing something about its density? Something that makes it to the point where we can't, I mean, literally anything that goes in it is gone. That's why they call it a black hole. But it's not
exactly.
just teleporting or going to another dimension. Something's happening to it in that transition where it's still the object still exists as far as I think we know. We like to think it's destroyed, but it's going somewhere because it's not leaving anything afterwards.
So yes, it is going somewhere. It's going to move faster and faster the closer it gets to the black hole because of the gravitational attraction. The issue, though, why I say we're not going to land, if you are in that thing, you would learn, but you'll die. If you're not in that thing, it can't send any signal back to you once it reaches the black hole, because nothing can escape, as you said. So the problem is science won't learn very much by sending something into the black hole because nothing will come out. So no matter how many radio transmitters you've got on that thing, no matter how many lights it's shining out, all of those things will vanish together with the machine. And so in the end, sadly, we just don't learn. From our perspective, it vanishes, even though I agree it still exists in some form, at least as it crosses into the black hole. If it can't communicate to us, then we're not going to learn from it. And by the way, we do see gas fall into black holes. We see gas getting circled around. We see it get hotter as it gets sped up because you reach high velocities. That means it gets hotter. That means it shines light. And before it falls into the black hole, some of that light falls outwards and can reach us. But by the time it reaches the black hole itself, then everything goes in and then it's just dark. And so sending our own like man-made robot wouldn't really teach us more. It would still just at some point just vanish into the black hole and then we don't know what happens.
Well, that gives me anxiety even more because if you really, when you start saying it out loud, you start examining the fact that it's not only just sucking up an object. It's like smashing an egg with your foot or smashing something with your foot. There's remnants of something there. You can do whatever, you can send a signal anywhere, but once this thing enters a black hole, not only does it suck up the light that's around it, it sucks up gas. It sucks up things that are even hard to even, like you have to open up a window basically to get gas out of your house, but the gas still exists. You can see it fade off into the distance. This thing, there's nothing. That means even a signal, things that we can't perceive with our eyes that are just happening. Like my computer's sending up a signal right now to a satellite to be able to communicate or be able to access Wi-Fi. It sucks up that. And that's what I don't know. That's scary to me. That's a little bit freaky, but makes me want to understand what that is more. Is it just changing it or bring? That's why I guess people talk about it leading to like another dimension or something like that. I'm not saying that's existent. I'm not, but I'm saying it might be plausible, sure. But I'm not saying from the science we know that's not existent. But what I'm saying is the fact that it takes it out of our reality, that there is none of that anymore. That is interesting.
It is. It is. Yeah. It's one of the fascinating things. What falls into a black hole, or from our perspective, is lost forever. And that's a fascinating and almost philosophical sort of conundrum. In fact, there is something called the information paradox, which is there was an idea that maybe information, like when you smash an egg, in principle, with a good enough detective, you can work out all the properties of that egg if you reconstructed that egg very, very carefully. Even weeks or months later, you could still, in principle, with enough effort, reconstruct what the egg was. But if something falls into a black hole, then you cannot, even in principle, no matter how much money you spend, no matter how good your technology is, that object has just gone from anything which wants to stay outside of the black hole. So you've lost that information. And it's not clear if or how you can resolve this.
Has there ever been any plausible ideas of what exactly happens when it goes inside, besides just being sucked in and then vanishing from, not being able to send a signal back? Has there been, because I'm thinking in my head is just like, how when you stretch something too much and it becomes really, really thin, I'm thinking it's something like that, where it's something on like a microscopic level that just, I mean, it's enough to pull in gas as well, too.
Right, right. Yes, there's something called spaghettification, which means basically that the strength of gravity gets stronger and stronger the closer you get to the black hole. Um, so if you went in feet first, your feet would be pulled more than your head because your feet are closer to the black hole. So your body would literally get stretched out as your feet would fall in more quickly because they're closer than your head, which is further away. So you get all stretched out. Spaghettification is a kind of nice visual image, also a bit disgusting.
It,
Of
it,
what's
ma-
happening.
it makes me think of Willy Wonka, where the kid gets stretched out.
Right, right. So, things you would expect things to get damaged as they fall in still exist, but they'd get deformed. And how much depends on the strength of the material and the size of the black hole, things like that. But what happens then once it's inside, if that process just keeps going as it reaches the center, or, all bets are off really, because we can't test that.
What are you using for your research or being able to understand these a little bit more?
Um, So it's a mixture of mathematics is the main answer. Mathematical equations which try to model things like the size of the black hole, the mass, how quickly it rotates, sort of what's the angular momentum of the thing. Sometimes I have to use computers like simulations because some things just are mathematically too complicated to solve on my whiteboard you see behind me. So at some point you have to go into a computer. I personally don't do anything with observations, but other people are looking for these things. For example, they're looking for gas getting heated up as it gets accelerated into a black hole. Or I don't know if you've heard of LIGO. They've seen the gravitational waves caused by two black holes circling into each other and literally smashing together. They see what happens, not directly, but they see the gravitational waves, so the sort of shaking of space around the black hole, which radiates outwards because it's not coming from inside the black hole, it's coming from outside the black hole. And it radiates outwards and shakes their detectors in a very, very, very small way. Very, very faint, nothing to be afraid of. But with good enough technology, they found the signal. And actually, an interesting historical note, they found the signal almost exactly 100 years after Einstein predicted gravitational waves should exist. I mean, really within a few months of 100 years later.
It's kind of eerie.
It's pretty amazing. Yeah, so that's a really exciting way to look at the universe using not light but gravitational waves, and the field's become more popular since then. So in the last 5-6 years, many more people have started working on this because we're just able to see, again, not really see by eye, but indirectly see the fact that there are black holes and that sometimes they smash into each other, which is a very violent event. It creates a lot of energy. But again, that's not going to happen near Earth. That's not,
Yeah.
you know,
I'm my fears are calm on that aspect of things.
yeah.
But has anybody ever thought that, like, if we can't see a black hole and we just notice that it's there because of either measurements of gravity or if you're looking at gas that gets sucked up into it, did anybody ever think that maybe the Big Bang didn't create a black hole, but the black holes were just always there?
Um, not so. If you go again backwards in time, the universe got smaller and smaller because today it's growing outwards. At some point, if our theories of gravity are correct, as you push them back to the very, very early universe, the whole observable universe today is smaller than any of the black holes we see in the universe. So in that sense, they can't have existed before the Big Bang. They don't fit into the universe before the Big Bang. That they kind of need to be a creation from the Big Bang. Or our theory simply is breaking down at very, very early times. Because we're talking about very extreme densities, very high temperatures, We're talking about things you cannot recreate in a laboratory. So it's always possible that, like Einstein's relativity theory and quantum mechanics, are simply not valid at some really, really early time when the energy is going crazy.
I think it's more plausible that it helped us discover a lot, but I also see so many scientific theories that 10 years later end up becoming false, and there's a new idea of concept of what it is. But just understanding a little bit more about dark matter and dark matter kind of always being there. I mean, there's a concept that you can really fight the argument that was dark matter there before the Big Bang was created. We know the Big Bang creates everything because it starts showing visual promise of light and all these other things that start to happen afterwards. But what about things that weren't able to, like, if a black hole, if you can't see it, you can just see things get sucked up into it. How do you know if there was nothing for it to get sucked up into? You just wouldn't be able to measure it. You wouldn't be able to understand if it was even there. I mean, it's just an idea. Like I said, I'm trying to understand this a little bit, but I think it's plausible. I mean, we're basing everything off of that the Big Bang created everything. I think that makes sense, and I think it's helping us understand a lot. But what happens to get to the question of what created the Big Bang? There had to be something there before, whether it was visual or not, whether it was large scale or not. There had to be something before the Big Bang. What created it? Could be a reaction to something. Could be like a magnet where two of the same sides, they want to repel each other apart. I have no clue. But it brings into the question where you start looking more at dark matter. I mean, is this a concept? If this is how the universe, everything is made up of dark matter, was there some type of reaction that happened or some type of something that happened that caused this giant explosion? And then that's where we see black holes.
Um,
The thought, it's a thought,
yeah,
not
sure.
fact.
Yeah. At some point, I think our imagination and even our mathematics and physical theories just break down, or at the very least, they become untestable because nothing existed then, or at least nothing we know for sure of existing today existed then. And you cannot recreate anything in the laboratory, no matter how good, even in CERN in the LH in Geneva, where they're smashing these particles it's an amazing experiment, but still you can't go back in time or reach the energies of the universe early enough in time to really probe the very beginning. Um, at some point, it becomes even unclear if this is a scientific question, because if you can't test it, even in principle, even with any amount of technology, it's kind of reaching the realm of philosophy. That's right. Yeah, science should be about what you can test, at least in principle. Even as I said with Einstein's relativity, like gravitational waves took 100 years. But nonetheless, it was clear if you had a very, very good experiment, you would see a gravitational wave eventually. And they did. It just took a long time. In terms of what happened before the Big Bang, I think there's no way, even in principle, you can know that.
So my
Or at least there's
question is
nothing I can.
valid. My question is valid. Technically, you can't prove it's like Russell's teapot. You can't prove me wrong. You can't prove me right either. That's the conundrum of it.
Yes. Yeah. And so I think it becomes then a question of what's plausible. Is it reasonable to believe that given what we know that came later or not? But you can't prove it either way. I think that's right.
How much of this I would say is conflicts with the philosophical approach? Like, because if you ask the question if it's plausible, like that something existed before the Big Bang, I mean, you could also fight the other side that it would be kind of stupid to think that one thing created everything. And then when you ask the question, what created that thing? Something had to. And then people say God, and I hate that answer. You can't use that answer. It's a cure-all answer. I'm not saying I'm not religious. I'm just saying you need to it would be cool to know what created that Big Bang, which obviously we're figuring out. But I mean, how close is this aspect? Like you mentioned, it's more like it can kind of go into the philosophical stuff. I mean, people could take a lot of meaning out of something that literally vanishes everything, and we don't have an understanding of what that really is. No way to really test it as well, too.
Yeah, it's very difficult. What are you meant to do when you can't even prove it? With Russell's teapot, I think you can make very good arguments that it's implausible that there's a teapot circling around the solar system which predates humanity, but you can't disprove it. But right, I think most of us reasonable people would agree that there almost certainly isn't such a teapot. Um, with the Big Bang, I feel like there's much less we know about the beginning, right? Much, much less. So with the solar system, we do know there are asteroids. We know none of them look like a teapot. None of them are made out of the same material as a teapot. To me, that seems like sensible evidence against the idea of the teapot, even if it's not a proof. With the Big Bang, if you don't even have a sort of good idea of what you expect to be true, then I'm not sure you can even like assign probabilities of I 10% believe this versus 90% something else. I'm not answering your question, okay? I'm just saying maybe
you
why this
mentioned
is
Russell's
not
T.
what we do as a scientist, because we want to maybe focus on things where we believe that the answer will be known in the future.
But wouldn't science also be attempting or thinking outside of the box compared to the average norm of something that's been conceived for the longest time as well too? That's why some of these theories get disproved. I mean, I think it's important to understand that like we do boil down all the basic concepts that the Big Bang was the very first thing, and we might not have abilities to be able to measure what was before that. But I think it's plausible to kind of accept any idea on it as well too. I mean, me saying that there was black holes maybe before the Big Bang is not going to change any revelation in science at all. Um, but I question like the idea for me for one thing creating everything, and I understand that, but I just I don't think that's always 100. I don't know. That just seems a little bit far fetched. Also,
Right. So,
I'm not dismissing the Big Bang. I'm just saying it's. I mean, it's equally kind of conceivable to understand that as well too, because we don't like to think that something just pops out of existence or randomly happens. And you have this traumatic event that created so much, where it's like, what caused that? And then the answer is we're figuring it out, or I don't know. I start going. Did anybody ever toss out the idea that there was something before that, like something that we couldn't be able to measure?
so yes, the answer is for sure. People have got ideas about this. In fact, my cosmology lecturer in Cambridge, when I was a master student, is one of his famous ideas in collaboration with others, he's called Neil Turek, was called the cyclic universe. So the idea that the universe grew up to some maximum size, then through gravitational attraction, it turned around, it started shrinking, and it collapsed. And then at the collapse, it didn't just collapse into a black hole and that was the end, but that it bounced back outwards. And so you've got this idea of the cycle. So it grows, it stops at some point, then it shrinks back in, goes bang, big crunch to a big bang, goes out. And that pattern could keep repeating, perhaps forever. And so people have looked at that idea. It's very, very hard, as you'd imagine, to test. There are some ideas of how you might test what goes through the Big Bang, and it's not very satisfactory, though. Like the equations basically break down at that moment of the Big Bang. So you have to do some educated guesswork of how you might continue what was happening just before the end of the crunch to what happens just after the explosion coming out. And the problem is your answer depends on how you guess your equations continue across that sort of unknown period. And so I'm not dismissing the idea. I'm just saying it's not very satisfactory because you have to make assumptions and you test relative to those assumptions, but those assumptions might be wrong. And you can't kind of independently test your assumptions and the idea. So whatever you find, you'll never really be sure if your assumptions are wrong or if the observations are not what's right.
Well, that's like a difficult area just with space in general to be able to test things because you're limited on resources and you're limited on technology as well too.
That's right, that for sure. But this is sort of going even deeper than that because here we are even limited by the fact that we can only observe things so much later. And then there's really this in principle fact that light has only been able to travel a certain distance and it's for only a certain length of time. So is you're right. There's a difference between give me like $1 billion, what could I find out? There's a bunch of stuff science could do, but going back to the Big Bang or really telling you what happened at the Big Bang, I'm pretty sure is not one of the things we could do. I mean, forget about a billion, a trillion, whatever money. I think there's just, no matter how much you throw at it, there's physical limitations which you just can't beat. Like causality, the fact that we can't travel backwards in time. I don't think that's got anything to do with how much money you've got to throw at technology. It's just a principle. You don't turn back the clock.
I think there's basic distinctions that we've all kind of agreed upon, like gravity and all these things. Those are set in stone. I'm not trying to change those. Just tossing out an idea. I mean, how many black holes are available in our universe or our solar system or galaxy compared to another galaxy? Because I mean, if we're talking about black holes, is that eliminating information over a slow period of time? You know, not maybe not in our own, but in other. I mean, I looked at the number of exoplanets, and it has increased dramatically over just the past couple of years. We started discovering way more, and I start going, okay, but what about the ones we missed? As maybe one of those happened to hypothetically get sucked up into one of these black holes.
Should have happened, yes. So in, say, our solar system, sorry, in our galaxy, the Milky Way, there's something like 100 billion stars, right? That's a hard number to imagine, but nonetheless, it's a finite number. We don't know very well how many black holes there are. Might be yeah, certainly in the millions, but whether it's, could even be a billion, I mean, maybe more if there are primordial
Lowball
black
me,
holes.
lowball
I
me.
mean, that sounds scary, but we're still talking, there's more stuff in stars than there are in black holes inside the Milky Way. And we know that because of the gravitational attraction of stuff. We know that most of the stuff is shining light. And we know also in the center there's a supermassive black hole. In the center of the Milky Way, and then probably in the center of every galaxy, there's a massive black hole, which again is exciting, but we're not going to fall into that. Nothing so far away from the center of the Milky Way as we are is ever going to get sucked into it. Some planets probably have been sucked into some black holes. It's not something we've ever seen though, and it would be, I guess you'd have to be looking at the right place at the right time to see the effect of the planet slam into it. After it's got sucked in, then there's nothing left to see. You'd have to see at the moment when it happens. And that's going to be hard because you don't know in advance where it might happen.
Or if you were able to measure it before it got sucked up into a black hole and notice that there's no sign of it anymore.
Um, Thing is, in principle, but this thing's going to happen quickly. So you'd still have to be looking at basically exactly the right time. And these things are very hard to see. So if you're looking for a very rare event in a very big space, and space is very big, it's like looking for that needle in a haystack. You have to be incredibly lucky to see things, especially imagine these needles were popping out of existence, or very, very occasionally they're like, there were people threading the eye of the needle. It's already hard enough to find a needle. Now you're looking for a needle at the moment when something exciting is happening to that needle. It's even harder to find such an event.
When did the event of black holes become like actual plausible and kind of, not more than just a figment or an idea? I know when the creation kind of started of it, or we mentioned earlier, but I'm curious because I mean, if you look at how vast space is, if you're looking all around space, what happens if you thought something got sucked into something? There were signs of something there before, and now it's not there anymore. Could it just be space is so vast that you're just misplacing it?
Yes. Yeah, it can be. And that's a challenge. Honestly, when did they become generally accepted? I think it's certainly in probably in our lifetime. So the idea
That's
really, it's not that long ago. Let's say, for example, work by Stephen Hawking and Roger Penrose showed not just that black holes could exist in principle, but that there were realistic configurations of real stuff in the universe, the stuff that makes up stars, which could, under gravity, collapse by enough to form a black hole. that idea, or the acceptance of that idea, is not that old. Even though philosophers, or let's say dreamers, had the idea of the black hole, actually, I think hundreds of years ago, then it was just seen as a curiosity, but not as a real thing. So sometimes, actually, the curious are ahead of, you could say, the science.
Well, it's kind of like any PhD student that, does a research project. Most of the time, you're waiting for your funding after you've already done the research project.
That happens too.
Yeah.
Except here we're talking about a much larger timescale, I hope, for the poor student.
I wonder when they first kind of made it plausible that black holes exist, but also the concept of what happens when two smash into each other. I mean, is that a more cataclysmic event? Is that just going to explode everything, like kind of like a singularity type deal where we're dealing with something that's a massive explosion like a Big Bang, or is it just something that happens like one sucks up the other?
One sucks up the other, and it creates a bigger black hole. Um, Roughly speaking, if you have, say, two black holes of the mass of the sun, then they would form a new black hole with twice the mass of the sun. It's not quite true, because some of the mass gets converted into energy. Einstein's famous equation E equals mc squared tells you that the energy and mass can kind of be converted. And in that moment of collision, some of that mass comes out as energy, which is pretty amazing. But nonetheless, it forms a new black hole. And that event has been seen with gravitational waves. So they've seen, again, indirectly seen, detected the fact that two black holes have hit each other and created a new black hole, which is more massive than either of the original ones. And they've seen that now probably about 50 times. So it's a whole new field of science, gravitational wave studies of these very, very compact objects, either neutron star or black holes smashing into each other. Yeah, it's exciting stuff. It's worth keeping your eye on, because in another 5 years' time, we'll probably have 1,000 or so events.
Do any of those events, or I know it's for visually, combining into one giant one, but does that have any like ripple effects or anything just on the air and space, or not air and space, there is no air and space, but just the events in space around that event?
Yes, so they have a ripple effect on space itself, on space-time. They literally shake up the fabric of everything of space-time around them, which
Over
is
my
called the
head.
gravitational wave. I know. How do you explain this? I mean, it's not something I can visualize, although LIGO, the scientific collaboration, and collaborators Virgo, etc., they've created these computer graphics. And they're beautiful, but they're not actually what you'd see with the naked eye anyway. But it does shake things up, and it's that shaking which travels through empty space and reaches the detectors on Earth and gives them just a gentle, gentle shake. And that gentle shake, with brilliant enough technology, is what they interpret as being two black holes smashing into each other. It's amazing. And the reason why they trust it is because they've got separate detectors on opposite sides of the US, for example. And they see the same signal at almost exactly the same time. And there's no way that any noise from Earth, say a truck driving past, it will affect one detector but not the other. So they're looking for the same signal coming from outer space, hitting both of them at the same time, because this signal is traveling at the speed of light. And so it's pretty mind-blowing what they're doing. And it's
Complicated.
yeah, it's really exciting.
What's one of the questions that you have for black holes in general, or any of your research?
I mean, the underlying question.
Don't say how the universe is created.
I mean, no. First of all, are any of these black holes, which they have seen, and I don't think anyone seriously doubts they've seen black holes crash together, are these black holes astrophysical, meaning are they dead stars, or are they primordial black holes? For me, that's like $1 million question. Very exciting. Did they form in relative terms a long enough time after the Big Bang because the star went supernova and collapsed? Or did they form in the first second after the Big Bang? And that's a big question. Now, it's just very hard to tell, because, as I said at the beginning, once you've got the black hole, you've lost the memory of, there's no sort of direct visual signal of how it formed. So we've got to guess it from the properties of the black hole. Um, and then the dark matter, another thing you brought up, we know from observations of rotation curves, for example, of stars going around the galaxy, that there's more matter, there's more mass than we can see through light, through the stars and through gas clouds. There needs to be something else. And is that something else primordial black holes? Or is it some new particle which we haven't managed to detect in any collider? Or is it our theory of gravity is breaking down? We don't know. But there's something sort of missing. There's some extra component which is dark. And people have known about this for at least 50 years. The first idea is a good 100 years old. But the first little hint of observational evidence goes right back to the early 1900s. But we still don't know on a detailed microscopic scale what it is. So that's a big question.
Now, if primordial black holes were created at the Big Bang, you would consider that a traumatic event, right?
Um, I say it's an exciting event. it
It's
requires
powerful.
something quite extreme. Yeah.
Yeah, it's powerful. So if you get to a star dying and creates a black hole, that's a powerful event as well too. So is it possible that these are just tearing into the fabric of space? That these black holes are created, that it's just literally like if you take a piece of paper, the paper is space and you're poking a pencil through it and you're making a hole. That's what this is. There was a heavy impact that caused this creation. So in some ways that they're similar, not just the name black hole, but a black hole formed from a dying star compared to a black hole that was primordial or created at the Big Bang are essentially similar in the aspect that they could just be giant tears in space.
Kind of, yes. As in, once they're a black hole, they are a traumatic, in quotation marks, object. They're just mind-bogglingly extreme. Imagine trying to crush something a million miles across down to a few miles. You shrunk it by a factor of a million. That means the density is grown by, well, the inverse of the volume, so a million cubed. It's just, it is a mind-blowing event for this to happen. It's still, though, the mechanism, why it would happen from a dead star is very different from why it would happen at the Big Bang.
The mechanism can be different, but the overall outcome or the effect of what that hole does is relatively similar.
Yes, yeah,
So,
that's right.
I mean, if we have technology now that can project things on air, just particles. You don't need a projection screen anymore. You can just project like a hologram basically in front of somebody. They're using it in academia now. So I get to this point, if you get to what I would traumatic just means something happened, an impact happened, or it's the best way to describe it. It doesn't mean it's horrible. It just means something happened. Where I bring up the paper example again with a pencil going through it. If you had something that just happened, an event that happened, and it just created this hole, or it can be an explosion, it could be whatever, but it leaves the same effect where could it, you know how you talked about spaghettiing before, kind of like this aspect of like your feet and all that stretching out. What happens if that's just the air, literally the dimension of space? It's like since it is a hole, it's all getting sucked in. So it's getting that spaghettiing effect, but that's why it's sucking up everything into it. I mean, could that just be black holes are created from an impact of some sort? You could say Big Bang. There's probably various different ways it can be created, but overall, it's just like a rip in space. It's rip literally in this concept of what this thing is, which obviously leads more into a more full philosophical area.
Um, I mean, yes, indeed,
I'm
collisions
trying, man. I'm
are another way.
trying.
Yeah, yeah, yeah. No, collisions are another way, potential way to create a black hole. And there was fear, I think, completely overblown, but the idea that in CERN, when people crash particles into each other at very high velocity, that they could form microscopic black holes. So people thought about this idea, and it's never been seen to happen, but in principle, the equations of gravity do allow that to happen.
Isn't that why they shut down the Hadron Collider? Was because they were afraid that they're going to create a black hole?
No, no, that's not right.
Oh, I was pretty sure I read that somewhere.
There's been all sort of overblown fears about this, but no. It's been shut down various times for upgrades or because of technological problems. It's an incredibly ambitious thing that they've built. It's in a sense very delicate. You're trying to accelerate particles to nearly the speed of light and going in a circle. So you've got to guide them to stay in the vacuum of these tubes which are going around in a massive circle. And but no, the serious people sort of working on that, they're not afraid of that, and rightly so,
I
I should
don't
say.
think it does that, but I think that leads more weight into the point of it being an impact in space, that what these things are. I mean, if we talk about we don't know what happens when it goes onto the other side and it can't send us signals, the only thing I can think of that has changed the fabric of reality, or the one that everything else is kind of going by. I don't mean it like in a weird sci-fi term scenario. I just mean that's literally like something just it's like the cartoon thing where it's just nothing. You go in, nothing comes out. Something happened and something it looks like it punctured. If you're talking about a hole is usually go it doesn't just go somewhere, but it's an aspect of like it's a hole. It's a puncture. And I just think that's that's plausible in my sense.
Hmm. I mean, for me, that is the vision of two particles, or two small things hitting each other really head on with enough energy to form a black hole. And that's one way that the Big Bang had basically unlimited energy. So it's perfectly plausible that it created the black holes then. But these would be very small black holes. And the massive ones that have been seen through gravitational waves, I don't think it's plausible for them to be formed by two things colliding, because there just aren't big enough things traveling with enough energy to form them.
Well, if the Big Bang created primordial black holes, if you're able to trace and see if you could find the significant impact of where the Big Bang first started, where that impact was, where the center of it was, and you're able to trace around it. I mean, if it's filled with energy, does the energy dissipate at a point the farther it goes out, like, normal things do, or does it just continuously keep going? And check primordial black holes. Are there a bunch around where the impact was, or does it, you see them sporadically pop up everywhere?
So let me take you back to the idea of where the Big Bang was. The Big Bang was everywhere. The Big Bang was the whole universe.
Damn
So
it.
you can't like point and say the Big Bang was over that side. No, the Big Bang was everywhere. It was everything. So it's not an explosion in an empty space, it's an explosion of space itself. I mean, and that's why the analogy of the explosion breaks down, because it's everything all at the same time. I know, but it's very hard to, so there isn't a bindle, there isn't a center. Everything, or if you want a center, everything is equally democratically in the center, because it was everywhere. So what we see on Earth is the same as what an alien civilization in another galaxy would see. They were just as much in the center of the Big Bang as we were, because we were all together in the same place at the
No,
beginning.
I get it. It's just the conundrum of it's the conundrum of trying to understand the Big Bang. It's probably one of the toughest questions we've ever faced. Only on the concept of because it's like a snake biting its own tail. Like if you start going when something happens or something's created, that means it's a start point. But what happens if you can't find out how it started? It brings to the question, did it always exist? Well, we know it didn't always exist. Something happened. It was an event that happened. Okay, so how do you trace it? We don't have the technology to be able to check before the Big Bang. We're trying it, we're figuring it out. But then it goes to the point of, okay, well, where was the impact point? Well, the impact point is everywhere. It's like, well,
Everywhere, that's right.
so you're always running into basically a wall every time you try and answer the question, which I think it leaves a lot up to theorizing. And I think a lot of theories are obviously plausible, but I also think it's very, very interesting because it's kind of like one of those mysteries that people always love to solve. Mostly on the concept, people like to solve mysteries when it's like a murder or something. This is a little bit more, less killer. This is more like, you're trying to solve how the universe was created. And it's one of those things where you're limited. It's like playing Scrabble, but you only have four pieces.
Yeah, yeah. There's certain things you just can't find. You can't see them, even in principle. Those, or let's say, it's more like playing Scrabble, where some of those pieces have been destroyed. For example, have been thrown in the black hole, and it's just not possible with no amount of technology to get those pieces back. They're gone, so you'll never know what were in those letters. I think that's a better analogy. That is just lost to humanity.
So do you think the answer is getting easier or it's getting harder with the more time that goes on?
Um, to be honest, in the scale of human civilization, the the amount of time humans have been around is just tiny compared to the age of the universe. So the universe hasn't really changed in the time humans have existed. Technology improves certain things. We certainly, what we can see, we see better and better. But what we can't see, we just, by definition, can't see. We'll see more and more gravitational waves. We'll see more and more compact objects. Hopefully, we'll find out what dark matter is, whether it's a primordial black hole or whether it's a new particle. There's all sorts of different ideas of how to detect it. It's just none of them have hit the jackpots. And it might be a whole bunch of different things. Dark matter might be a whole combination of primordial black holes, different type of particles, and you know, exciting times. But equally, there's no guarantee we'll find out the answer because we're looking where we can look. We're looking where the technology allows us to look, and there are all sort of blanks where we don't really know how to look for them.
I'm curious, do they have conferences where there's like an open discussion about this besides certain institutions talking amongst other people that work at those institutions? Like there's overall meetings just skepticizing these ideas. Because like what me and you are doing, I hope our scientists are doing as well too when it comes to just reaching out from different countries and everybody getting an input. I think these theorizing of, ideas about this type of stuff are trying to solve it. I think it only adds just more weight to the discussion because before, if you would have talked about this 50 years ago, 100 years ago, nobody would have even taken you seriously. And now it's relatively, seen as it, well, it is an academic thing, but it's just more interesting to see the discussion evolve.
Hmm. Oh yeah, and absolutely there are conferences. And before COVID, I was traveling a lot to share ideas, to learn ideas. There were panel discussions, there were presentations, posters, and that sort of slowed down in recent times. But oh yeah, there's plenty now. There's also online conferences. So people go and have ideas, they have debates, and you have, drink tea or a beer together and keep discussing after the conference. Sometimes you write a paper together if you meet a new collaborator. These ideas are out in the open, but some ideas, let's say, have more people working on them and more success because we're at the point where we can probe them, and other ideas are just so hypothetical that, like this idea of the cyclic universe, even though I was learning about that about 20 years ago, I might be wrong, but in my opinion, not that much has changed in the meantime because there's just not much that's been possible to be able to say about it that's new. And so there's less effort on things where we feel there's not much progress and where we think even if we made a lot of effort, there still wouldn't probably be much progress.
Well, I'm happy the discussion is at least leaking out to at least the general public a little bit too. I'm seeing more and more articles about, black holes. It's more dimensional stuff is I guess what my probably algorithm has be hooked to because it's where I'm interested in. But I think it's just the fact that there's a lot more open speak about it when before, it wasn't even talked about as an idea.
I think that's right. It's grown in popularity. It's again, I think, a lot to do with the gravitational wave detection. It's just that caught people's imagination. It won a Nobel Prize, and there was then another prize, Nobel Prize for black holes, partly going to Roger Penrose for the first singularity theorem, or one of the first. And yeah, the public love it. So, here we are talking, and I've given talks to astronomical societies and Café Scientifique and all different sort of things like that. So, and you can even marry the idea of a black hole and extra dimensions. In fact, I've got a PhD student, Itzi, who's working on this idea of how would black holes change with extra dimensions? Would it be easier to form them? Would there be more of them, etc.? But you're still stuck with the problem that it's very, very hard to probe a black hole, and you can't see what's happening inside it. So it's a very difficult problem.
It's a complicated one I'd probably end up losing sleep over, but it's been a pleasure chatting with you, man. Is there a place where people can find any of your links? Do you have any social media handles, a website where your articles are?
So website, if you type in my name, Byrnes, Byrnes, and then Sussex, because I'm at the University of Sussex, you'll find my page there. I'm not much on social media, but you'll find like links to articles and a few popular science articles as well.
Well, good for you for not being on social media. It's a task and a half. But I'm going to link all your links in the description. It's been a pleasure chatting with you, and thanks for listening to this episode of Out of the Blank.